Welcome to the first lecture on linear algebra. Our linear algebra journey starts with matrices. Do you know what's a matrix? A matrix is a collection of numbers ordered in rows and columns, like this one, for example. This matrix contains the numbers 5, 12, 6, -3, 0, and 14. Each of these values is an element of the matrix. So, our matrix has a total of 6 elements. To make it clear, we are dealing with a matrix. We put all the elements in brackets. We would normally denote a matrix with a capital letter, for instance, A. Our matrix A has 2 rows and 3 columns. In linear algebra, rows and columns are the 2 dimensions of the matrix. A has 2 rows and 3 columns, so we say its dimensions are 2 and 3, or better, A is a 2 by 3 matrix. Normally, we would take note on that and put it below the letter A. Okay, matrices may seem like tables and spreadsheets at first. However, the purpose of matrices is not simply to store values, but to be main characters in mathematical operations. 2 matrices can be summed, subtracted, multiplied, and divided. So linear algebra is similar to algebra in the types of operations there are, but differs in how and when these operations are implemented, and if they are permitted at all. We will discuss all of that at length in this section. Okay. A matrix can only contain numbers, symbols, or expressions, with the idea that the latter 2 are nothing more than a generalized representation of numbers. For instance, the collection of these 6 symbols, A, B, C, D, E, F, show a different 2 by 3 matrix, say B. Here's another one. C. C has 4 elements and is a 2 by 2 matrix. Its incumbents, however, are not values, but expressions. Great! What about the size of a matrix? Matrices can be of any size. In the general case, we are talking about an m by n matrix. If A is an m by n matrix, then this means it has m rows and n columns. Sometimes we need to reference a particular element of A. The elements of A are denoted with a lowercase a and 2 numbers indicating the respective element position in terms of row and column. For instance, Aij is the element at position ij, where I is the respective row and j is the respective column. Therefore, if we want to fill in the matrix, it would start from A11, then A12, A13, until A1n to finish the first row. Similarly, we've got A11, A21, A31, until AM1 to complete the first column. The last element of the matrix is AMN. The total number of elements is m times n. Okay, great! To finish off this introductory lecture, we must note that in most programming languages, albeit not all of them, arrays start from 0 rather than 1. In Python, for instance, arrays start from 0, so keep that in mind when coding. All right, in our next lecture, we will look into vectors. Thanks for watching.